Swayam Prabha. Digital India. Educated India.
Now comes a demarcation wherein there are certain materials which are hydrostatic pressure sensitive and certain materials which are hydrostatic pressure insensitive. Let us understand what we mean by this. Now we got G as a function of K1, K2, K3 equal to 0. Now there is a demarcation as hydrostatic pressure insensitive and hydrostatic pressure sensitive materials. Okay. What do you mean by hydrostatic pressure sensitive and insensitive material is, if I take a sphere of a particular material and immerse it in a specific ocean, will it fail? When I immerse a sphere of a material in a specific ocean in a fluid, it is subject to an hydrostatic pressure. What is hydrostatic pressure? Hydrostatic pressure is the state of stress where there is no shear stress in any plane. Will such a state of stress cause a failure in a material is the question we are asking. It turns out that there are many materials like steel, metals in general which will not fail when it is subject to an hydrostatic pressure. Hydrostatic pressure can be compressive or tensile. Okay. In any of these stress states the material should not fail, that is in stress states which are purely normal stresses, there is no shear stresses, these materials will not fail. Such materials are called as hydrostatic pressure insensitive materials. On the other hand, materials like glass, concrete to some extent in tension fails due to hydrostatic pressure. Okay. So, these materials are called as hydrostatic pressure sensitive materials. Okay. In general, you associate hydrostatic pressure insensitive materials to what is called as a ductile mode of failure and hydrostatic pressure sensitive materials to what is called as a brittle mode of failure. Okay. The difference is in ductile mode of failure the shear stress governs, the failure mode. Okay. In brittle material mostly normal stress or to a certain extent shear and normal stress can govern failure. Okay. Now a given material need not always behave in a ductile manner or in a brittle manner, this is again temperature dependent. So a given material in certain range of temperatures may be ductile and certain lower range of temperatures may behave in a brittle manner. Okay. So it is not that steel is always ductile and glass is always brittle. Okay. So you have to understand that. Okay. Next, okay, since the mode of failure is ductile or it is the shear stress that governs the failure not the hydrostatic pressure, these pressure insensitive materials are governed by the deviatoric stress sigma deviatoric, which we have defined in our previous lectures as sigma minus trace of sigma by 3 times identity. Okay. So this is called as a deviatoric stress because trace of sigma corresponds to the hydrostatic pressure and that hydrostatic pressure will won't cause failure in these bodies which are ductile, which shows a ductile mode of failure. Okay. So now instead of this depending upon G as a function of K1, K2, K3 or F as a function of general function of sigma, it will depend upon a special function of sigma d equal to 0 for ductile mode of failure. Okay. Since trace of sigma d is always 0, this will depend from similar arguments that we made before, this will depend upon G tilde of K2D and K3D being 0. Okay. This will depend upon K2D and K3D are 0, where K2D is defined as 1 of trace of sigma d squared and K3D is defined as determinant of sigma d. Okay. You can evaluate this in terms of sigma also, but that I leave it as an exercise, we will do it as and when required. Okay. Where K2D and K3D are this. When both normal stress and shear stress govern the failure, or both or normal stress alone governs the failure, still you have to retain the original form, which is K1, K2, K3 being equal to 0. This is a general expression for failure theories of this class. Okay. Now, there are different failure theories within the same hydrostatic pressure sensitive and hydrostatic pressure insensitive failure theories. We will study a couple of them in each of these cases. Okay. The hydrostatic pressure insensitive case, we will study two failure theories, what is called as the maximum shear stress theory or what is called as Tresca criteria, and the other theory that we will look up is maximum octahedral shear stress, more popularly called as von Mises criteria. Okay. Similarly, in pressure sensitive materials we will look up three theories. One is maximum normal stress or Rankine criteria. Second is Moore Coulomb criteria, and last is Drucker Prager criteria. Okay. So, you look up these three theories in brittle mode of failure and these two theories in ductile mode of failure. Okay.